NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve the nested logarithmic equation, exactly following the algorithm in the prompt. We will go step by step, stating domain conditions, and then simplifying the logs. Here is our example. We start from the equation. Log base g of x of log base h of x of f of x equals 0. Step 1. Use the definition. A logarithm equals 0 exactly when its argument equals 1, provided the base is valid. That gives the base conditions for g of x, and it sets the inner logarithm equal to 1. Step 2. Apply the same idea to the inner logarithm. Log base h of x of f of x equals 1 means the argument equals the base. The base h of x must also be positive and not equal to 1. Visually, you can think of the outer log forcing the inner expression to be 1, and then the inner log forcing f of x to equal h of x, while both bases stay valid. Therefore, following the exact algorithm, the solution x, while both bases stay valid. Therefore, following the exact algorithm, the solution set is this system of conditions: g of x not equal 1, g of x greater than 0, h of x greater than 0, h of x not equal 1, and f of x equals h of x. Step 1. Write the domain conditions for both logarithms. For a logarithm, the base must be positive and not equal to 1, and the argument must be positive. We apply this to both the outer and the inner logarithm. Step 2. Use the key logarithm facts. If log base b of c equals 0, then c equals 1. If log base b of a equals 1, then a equals b. Apply the first fact to the outer log to set the inner log equal to 1. Then, apply the second fact to the inner log and set the argument equal to its base. Step 3. Move everything to one side and solve the quadratic. We obtain x squared plus 4x plus 3 equals 0. Factor the quadratic to get x plus 1 times x plus 3 equals 0. So the candidate solutions are x equals -1 and x equals -3. Step 4. Check the domain conditions for each candidate. First, plug in x equals -3 into the outer base x squared plus 6x plus 8. That equals -1, which is not positive, so x equals -3 is rejected. Now, test x equals -1. The outer base is 3, which is positive and not 1. The inner base is also 3, positive and not 1. And x squared minus 2x equals 3, so the inner log equals 1, and the outer log equals 0. Therefore, x equals -1 is valid. The solution set is the single value x equals -1. Step 1. Use the rule log base b of a equals c if and only if a equals b to the c. Apply it to the outermost logarithm. Step 2. Any non-zero base to the 0 power equals 1, so the expression simplifies to 1. Step 3. Convert the logarithm base 3 to exponential form. Using the same rule again. Step 4. Convert the last logarithm base 4 to exponential form to isolate x. Step 5. Evaluate 4 to the 3rd power. Step 6. Write the solution set exactly as shown. As a quick check, log base 4 of 64 is 3, which is positive, so all inner logarithm domains are satisfied. Quick check. Log base 4 of 64 is 3, which is positive, so all inner logarithm domains are satisfied. Here is the problem. Step 0. Determine the domain of the innermost logarithm. The expression 2x minus 1 must be strictly positive. That gives x is greater than 1/2. Step 1. Convert the outer logarithm to exponential form. Now, apply it to our equation. Step 2. Simplify the right-hand side, for to the 1/2 is 2. Step 3. Convert the next logarithm to exponential form with base 2. Step 4. Evaluate 2 squared equals 4. Step 5. Convert the final logarithm to exponential form with base 3. Step 6. Compute 3 to the 4th equals 81, then add 1 to both sides. Step 7. Divide both sides by 2 to solve for x. Finally, verify it satisfies the domain x greater than 1/2. Summary. We followed this exact sequence. Verify it satisfies the domain x greater than. Example. We will solve the equation exactly following the on-screen steps. The problem is log base 1/5 of log base 5 of the square root of 5x equals 0. Step 1. Convert the outer logarithm to exponential form. If log base b of a equals c, then a equals b to the c, applying that with base 1/5 and c equals 0 gives log base 5 of the square root of 5x equals open parenthesis 1/5 close parenthesis to the 0. Step 2. Any non-zero number to the 0 power equals 1. So the right side becomes 1. Step 3. Convert this logarithm to exponential form again. If log base 5 of a equals 1, then a equals 5 to the first power. Step 4. Remove the square root by squaring both sides. The left side becomes 5x, and the right side becomes 25. Step 5. Solve for x by dividing both sides by 5 to get x equals 5. A quick domain check. Inside the square root, we need 5x greater than 0, and the arguments of the logarithms must be positive, which also gives x greater than 0. Our solution x equals 5 satisfies this, so the solution set is the set containing 5. Here is the example we will solve step by step. We will keep the work on screen as a vertical chain of implications, so you can track every change. Step 1. If the log base a of something equals 0, then that something equals a to the 0, which is 1. We apply this to the entire curly bracket expression. Since a to the 0 is 1, the left-hand expression must equal 1. Subtract 1 from both sides to isolate the next logarithm. Now repeat the same idea for the log base b. If the log equals 0, its argument must be b to the 0, which again equals 1. Again, if the log base c equals 0, its argument equals c to the 0, which is 1. That gives us a simple equation for the next layer. Finally, if log base p of x equals 0, then x must be p to the 0, which equals 1. That is our solution, provided the usual base conditions hold. Each base positive and not equal to 1, and x positive. The value x equals 1 satisfies all of these. Here is the problem statement. Read as log base 4 of, curly brace, 2 times log base 3 of, bracket, 1 plus log base 2 of, parentheses, 1 plus 3 log base 2 of x, close parentheses, close bracket, close curly brace, equals 1/2. Step 1. Convert the outer logarithm to its exponential form. That gives 2 times log base 3 of the bracketed expression equals 4 to the 1/2. Step 2. Replace 4 to the 1/2 by the square root of 4. Step 3. The square root of 4 simplifies to 2. Step 4. Divide both sides by 2 to isolate the base 3 logarithm. It equals 1. Step 5. Convert the base 3 logarithm to exponential form. The inside becomes 3 to the first power. Step 6. Since 3 to the first is 3, subtract 1 from both sides. Then log base 2 of parentheses, 1 plus 3 log base 2 of x equals 2. Step 7. Convert the base 2 logarithm to exponential form. The inside equals 2 squared. Step 8. 2 squared is 4. Subtract 1 from both sides to get 3 times log base 2 of x equals 3. Step 9. Divide both sides by 3 to get log base 2 of x equals 1. Step 10. Rewrite the logarithmic statement in exponential form x equals 2 to the first. Step 11. 2 to the first simplifies to 2. Finally, the solution set consists of the single value 2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.